My name is Minali Bouillon, and today I will explore the story of two species of barnacles living on the rocky shores off the coast of Scotland. The sound of the waves crashing in the audio clip transported me to the rocky intertidal zone. The intertidal zone is a place rich in ecological interactions. In this video, I will discuss the concept of niches and competitive exclusion through the story of the competitive dynamics of the intertidal barnacle species Balanus and Chthalomus. Before I start, I want to highlight the connection to indigenous two-eyed seeing. Two-eyed seeing teaches us to see through both Western scientific and indigenous perspectives. The Mi'kmaq perspective might see the intertidal zones as a space of reciprocity, where species interact and coexist in balance with their environment. Our story begins with Joseph Cannell, an ecologist who studied the patterns and dynamics of organisms in their environment. In 1955, along the coast of Scotland, he examined the distribution dynamics of two barnacle species, Chthalomus stellatus and Balanus balanoideus. Specifically, Cannell studied the interactions of these two species in the intertidal zone. The intertidal zone is a dynamic ecosystem that has a steep gradient of physical conditions from the shore to the sea. Organisms living here experience varying levels of exposure to air depending on their position. In the upper intertidal zone, organisms are exposed during almost every tide, requiring a species to adapt a resistance to drying out. But in the lower intertidal zone, on the other hand, species are submerged most of the time, creating conditions for species where desiccation is much less of a concern. Cannell observed that Chthalomus barnacles dominated the upper intertidal zone, while Balanus barnacles thrived in the middle and lower zones. He hypothesized that these patterns were shaped by a combination of abiotic and biotic interactions. In the spring of 1955, on the coast of Scotland, warmer temperatures alongside low tides and calm seas caused no water to reach the upper intertidal zone, where at the time both Chthalomus and Balanus were occupying. As a result, Balanus barnacles suffered high mortality rates, but the Chthalomus were much less affected. Cannell observed that the Balanus in the lower intertidal zone could survive, leading him to conclude that the Balanus was the more vulnerable species when it comes to desiccation or drying out. He predicted that this vulnerability was preventing Balanus from residing in the upper tidal zones. He also observed that Chthalomus larvae could survive in the lower intertidal zone, but very few would survive until adulthood. He then conducted a transplanting experiment, moving the Chthalomus from the upper intertidal zone to the lower intertidal zone. The results of this transplantation revealed that physical conditions were not causing the exclusion of Chthalomus from the lower intertidal zone, but instead it was a competitive exclusion by Balanus. This showed the importance of the biotic-biotic interactions, where Balanus was outcompeting Chthalomus for space in the lower intertidal zone. To further understand these dynamics, let's look at the concept of a niche. A species' niche is the range of environmental conditions that it can survive. First, a species has their fundamental niche, which is the full range of conditions that a species can theoretically occupy. And second, species have their realized niche, which is the area a species actually occupies, due to the competitive interactions or other limiting factors such as resources. In the case of the barnacles, Chthalomus's fundamental niche includes both intertidal zones, but because of competitive interactions with Balanus, it only occupies the upper intertidal zone. Thus, that's its realized niche. Balanus, on the other hand, occupies its fundamental niche and its realized niche because it can only live in the lower intertidal zones. Because Chthalomus is only occupying its realized niche, we can observe that competitive exclusion is occurring here because Balanus is outcompeting Chthalomus for the limited resource, which in this case is space for the lower intertidal zone. Both barnacle species have evolved unique adaptations to survive in their respective zones. Chthalomus, in the upper tidal zone, has evolved resistance to desiccation. During low tides, it closes its shells to conserve moisture, preventing drying out under the sun, while Balanus, in the lower intertidal zone, grows quickly and dominates the available space, thriving where desiccation is not a threat. These adaptations illustrate how abiotic-biotic interactions, such as exposure to air, and biotic-biotic interactions, such as competition, drive the distribution and survival of species. The Mi'kmaq principle of Iktukmuk, or two-eyed seeing, provides a deeper lens to view these interactions. From a Western scientific perspective, we see competition in niches shaping barnacle distributions on a base level with no further in-depth analysis. From an indigenous perspective, the intertidal zone represents a space of reciprocity, where each species adapts to coexist within the larger ecological balance. Cannell's study of Chithamulus and Balanus is a classic example of how ecological concepts like niches, distribution, and competitive exclusion intersect with the realities of abiotic and biotic factors. These barnacles teach us that survival is a delicate balance of conflict and coexistence, shaped by both the physical environment and the interactions between species. Through the crashing waves of the intertidal zone, we are reminded of nature's complexity and the value of seeing it through both scientific and indigenous perspectives.